Welcome to the fourth and final installment in a series on integrating the eTextbook, truly interactive textbooks for computer science education. This is part of C2 Gen, a Chautauqua program for the 21st century. Today I'm going to be talking about creating visualizations for OpenDSA, which means getting familiar with the JSAV library, which stands for the JavaScript Algorithm Visualization. It's pretty straightforward if you're familiar with HTML, CSS, and JavaScript programming. It's a collection of functions to augment putting things onto the screen and manipulating and changing them. The documentation for JSAV is at jsav.io. We see all the various pieces. Probably the most obvious ones would be the various data structures. The idea is that you create something like a tree or values in an array and it'll handle the layout for you. You can control that, but the less of that you have to do yourself, the easier it is. And then if you need to put in some lines or circles somewhere, you of course can do that. And there's specialized support for things like pointers to a node in a tree or in somewhere in an array. Code snippet objects with automatic highlighting of various lines, but just say highlight this line and it'll get everything sorted out for you. And some variable objects. Useful things for doing computer programming algorithm visualizations. So here's a quick list of key features for JSAV. You can put down an array, one or two dimensional arrays, linked lists, trees, both general trees and binary trees, graphs, and it'll automatically do graph layout for you, pointer objects, so pointing to parts of data structures, code displays, various graphical primitives. JSAV has its own support for popping up a question in the middle of a slideshow, a simple question, not sophisticated like the Khan Academy framework that I went through in the third presentation, but it's useful if you want to just check to see if the students are on track with the current slideshow. And then there's specialized support for the proficiency exercises. In other words, those are the exercises where a student has to manipulate the data structures to show that they understand how an algorithm works. One important thing about JSAV, this is partly by virtue of design, largely by virtue of being written in JavaScript, is that it's easy to write extensions. So you can pretty well overload any of the functionality if you want to. We've done this in a more formalized sense by creating packages to go with JSAV for things like binary search trees, red-black trees, Huffman trees. Heaps simply slave together an array in a tree, so whenever you operate on one, you're operating on its corresponding position in the other. 2-3 trees are kind of special because they use a special node type where the nodes themselves are arrays, and from that you could see you could do B trees and similar data structures. So let's take a look at some examples. The first one here is an example of a static image, simply a collection of rectangles and labels and such like. When we look at the code, it'll simply be a list of directions to put down the various objects. One thing I should mention here is that this is an example of what's called an inline visualization, and if you look in the RST file, it's invoked with a .inline AV directive. And what this means is that a lot of the boilerplate is done for you. Basically, to write one of these visualizations, all that you will do is create the JavaScript function to get what you want here, and perhaps a CSS file to specify some of the layout, look and feel, and so on. Likewise, this is an example of an inline slideshow. The difference between that and the ones that aren't inlined, the ones that are not inlined are HTML pages in their own right. They're placed into the module using an iframe tag in HTML, and that means they have to have a bit more infrastructure. Here, a lot of this infrastructure, things like these buttons at the top, the fact that it's placed in the HTML page and so on, all of that is handled for the developer, so they don't have to write nearly as much code. So let's take a look at what I had to do to create this. Basically, I just had to write a JavaScript function that has a little bit of boilerplate. I have to create the JSAV object and I have to give it the right name. This name matches the name that will be found in the inline AV directive in the RST file, and that in turn will match the file name for the JavaScript. Then you'll see that all this is just a series of directives to JSAV to put various rectangles and labels and things in the right places. easy to do. Anyone who is at all comfortable with JavaScript programming for client-side web development should be able to pick that up in a couple of minutes. In our next example, we have a very simple slideshow. It's simply going to show some text, and then it's going to put what turns out to be an array without any border around the cells, and then some arrows. So let's take a look at the source for that. Once again, all we see here is JavaScript because all the HTML parts have been handled by the system since it's inline AV. When you compile the modules, all of this gets loaded up properly. We have the name of this visualization, which not coincidentally matches the file name for the JavaScript file. A little bit of boilerplate here, and we have, in this case, a JavaScript array that we've created that will be used to seed the JSAV array, and you do have to get used to keeping the distinction there between a JavaScript thing like an array and the data structure that's being managed by JSAV for you with visual look and feel and so on. Some specifications for size and positioning and so on. Here we create our array. Now we actually are ready to do the slides, and it's very simple. We have the message for the first slide. The first slide gets display in it. It's just some initialization that always gets done the first slide of any slideshow. Then in the second slide, you may remember we put down the array, so we made this array visible, calling the show function on it, our array. We display some arrows, and we put down another message. We step the slideshow. Third slide, put down some arrows, put down a message, and then the last thing you do for a slideshow is to end it by saying this recorded method. One thing you may notice is that the text for the messages is not here. In one of the earlier presentations, I talked about how we support being able to write your strings in different written languages. So we could write this in Spanish or Finnish or English. So there's a JSON file that has a tag in it, AV_C1, and with that is the actual string to be displayed in whatever language I chose. We can take a quick look at that. This one's very simple because there's no code snippet here, there's no code block. All we have here is the strings that will be in here. In this case, there's no translations, but if someone wanted to add a translation in another language, all I have to do is add another section here with these tags and whatever the version of the string should be. Now in our third example, we have a little bit of manipulation on an array. This is the first iteration of an insertion sort. So you see we have an array. We've highlighted one of the elements of the array, and now we're going to do a swap. Now we'll unhighlight the array. We look at the source for this. We've created the JavaScript array with the values that'll be in it, and we create the JSAV object. We create an array object, and we use this JavaScript array to seed the JSAV array. This says that it's going to have the numbers at the bottom. And now we're ready to do the slides. Very simple. Tell the position one of the array to highlight. We are going to gray out some of the other positions in the array, so we give it a gray text class. Then we put up our message, and then we do display in it. You always do that on the first slide. Second slide, put up a new message, call the swap function. So there's a special function on arrays that understands about how to make it look nice like a swap. It makes things red and puts little arrows up and swaps the two values, a little bit of animation taking place there. Turn off the highlighting on those two positions, and we're done with this slide. Third slide, put up the text on the highlight, and we're done. Just to remind you of what happened there, let's go through this again. We did the swap and we unhighlighted. So now let's take a look at a regular visualization or a full visualization. Unlike these others here, you can see they're a slightly different color. You can tell that this is a different type of thing. These were fixed examples, and this one is a full visualization. It's got its own HTML page, its own CSS file. You iframe this whole thing in to the module, In OpenDSA, typically those inline slideshows have very little user interaction. They're just clicking the slides, and they're usually for a specific example, whereas these full visualizations have some mechanism for generating new examples. So each time I hit run, it generates new random numbers. If I wanted to, I could type numbers in here, and those numbers would appear as the makeup of the array. There's code snippet. You get to see something that the user has some control over. There's an about box, tells who wrote it, some background, tells which version of the library is being used. That's helpful for developers sometimes. So you'll notice this example generated 37 slides. Here, this example only has 32 slides. So you can see the slideshows being regenerated on the fly each time I push the run button. As I go through this, the current line of the code is being highlighted in time with the slide, and then the action in the array, what's being highlighted, and so on, changes. So let's take a look at what we've got here. First, there's the HTML file. So we have to load in some CSS files. There is some layout that's pretty standard. I'm not going to go into the details about this. It's the sort of thing that you can learn best if you sit and look at some examples. Generally, when I write a new visualization, I go look for one that exists that's as close to it as I can find, and I start working from there. We have a fairly standardized layout for a lot of things, particular form and with the run button and reset button and that sort of thing, and then the general area where you put down things that you want to display. Now the JavaScript to go with this, there's a function for the About button, and as you can tell, this is pretty stock. We've got functionality that basically you give it a string for the authors and a string for the title. Of course, those are in the JSON file that goes with this visualization, and everything gets built for you and all the handling of that gets done for you. Now what's different about this visualization from the others is that here we're actually instrumenting an algorithm. So this is an insertion sort. There's a lot of lines of code. Your normal insertion sort will maybe be 5 lines long, and this is considerably longer than that. But if you read through this carefully, you'll see that there really is an insertion sort underneath all of this, and the rest of this is pretty much commands to JSAV to tell it to display things. We've got write a message at the start, probably says something about starting insertion sort, and we highlight a particular line of code. This would suggest it's the signature line of the code. We highlight a particular position in the array, and then we set some values in the array to certain classes. We use this a lot, this add class method. We don't want to directly set CSS of things here. We want to, in as much as possible, we want to define the way something should look and then set it to look that way. And so this processing class is a CSS class that's been defined somewhere in one of the CSS files to what this means. Then we make the next step, and then we get into the outer loop of the insertion sort. And at each step through the loop, we'll set something to some color. The ith element of the array will be set to some color. Print up a new message, highlight the outer loop line, step to the next slide, print a new message. Then we're going to highlight the inner loop line. Now we're ready to do the inner loop of the insertion sort. As we go through, we're going to appropriately highlight or color the various positions in the array. And at the end, then we can highlight presumably the last line of the pseudocode, and we can put up the last message and so on. And here we've got the callback function for the run button, which basically initializes everything, setting up the callback functions for the about button, the run button, and so on. These are the initialization variables that get executed when the page gets loaded. Our next example is a proficiency exercise, a very simple one. The idea is to show how search works in a binary search tree. So the idea is at the beginning I don't know anything about the tree, and I know I want to look for 801, so I click on the node. And if I'm not sure how this works, maybe I should look at the model answer. I can step through and see in the model answer, get some idea of what I'm supposed to be doing. And then if I understand that, I can reset this. Let's try again and click here and here. I found it. And let's see, it gave me 6 out of 6. Good. How do we implement that? Of course, you can imagine these are going to be a little more complicated. The HTML page is generally fairly simple. It's pretty standard how these things are set up. They've got some instructions at the top and then a place where you put the interface that's being manipulated. So if you look at an example for a similar exercise, you'll be able to copy most of that and make a few changes and get what you want. So the difficult part will be in the JavaScript. Here we have an About button and set the click handler for the About button. The big things that you'll have is mechanism for initializing everything. So every proficiency exercise needs an initialization routine, and you'll need to generate a model solution. Every exercise has a function for generating a model solution that actually does two things. It generates the slideshow that a user can see when they want to look at the model solution, and it also generates sort of the markers for what the data structure has to look at for each step in the progress that is supposed to be made. And there's a particular JSAB method being called the step option for grade. What this means is, in essence, a snapshot of the array is being taken here. And when the user manipulates their array, what's going to happen behind the scenes is this series of steps that were captured during the model run of the solution will be compared against those steps that will be marked during the student's run of the algorithm. And if those steps match, then you get a point, and if a step doesn't match, you don't get the point. And then we have to deal with the interface itself. So we need click handler for what happens when the user clicks on a node in the tree. That when they click a node in the tree, things get highlighted, things get exposed, all of that gets handled here. And then we've got some variables at the beginning. Probably the single most important call in here is to the exercise object. And I said every exercise has a model solution, every exercise has an initialization. Then there's some information here that defines what exactly it is that's being compared. You'll have to read the manual for the details on this. So that's basically how you do a proficiency exercise. The last thing here is a more complicated proficiency exercise. From a developer standpoint, a big part of what makes this more complicated is that we have a lot of state to maintain. So this is a shell sort, and basically how a shell sort works is there's a first part where you select some values from the array in a particular way, and then you have to sort those values, then you have to sort some more values in a particular order. So there are various stages to this algorithm, and these buttons here indicate what stage you're in. So there's a lot of state to keep track of. Looking at the HTML page itself, that's not so complicated. And again, if you look at a couple of examples of exercises, you can pretty quickly pick that up. The JavaScript, here, the handler for the About button, and then here's code for the shell sort. Shell sort has sort of a main function here that invokes an insertion sort at certain points. Then there's this helper function called sweep. So these three functions make up the execution of the shell sort. Once again, you notice this step option, grade is true. Every time that happens, that's in essence capturing a snapshot of the state of the array. What will happen when the exercise is executed is that the shell sort algorithm will be executed, a big list of snapshots will be taken, and then the user will be given their version of the array and they'll manipulate it, and then as they do things, snapshots will be taken, and then the exercise will simply compare the steps for the user's answer against the steps for the model answer. This function here, generate increments, sets up some of the parameters for the question the student's asked. The student's given some numbers to use to guide how the shell sort should be done. So this is generating them. Sometimes setting up those numbers can be complicated because you have to come up with a problem instance that's of the right difficulty, not too hard, not too easy. In some situations that can be tricky to do. The initialization routine, remember every proficiency exercise, you have to have an initialization routine, what's setting up the problem instance. And then we have a series of callback functions for handling the buttons. Remember there are these 3 buttons there for setting the state of where you are in the algorithm. And so here we have 1, 2, 3 functions for the callback functions for handling those buttons. So there's some state variables to keep track of and so on. Now, fixed state. This is very important. This can be very difficult. Not every proficiency exercise has it. There are actually several ways that you can grade a proficiency exercise. One way, the simplest way to grade a proficiency exercise, is have the student go to what he's done and see how many steps he got correct. That, for simple things, is a good way to do it, but when it's more complicated, it tends to be that whenever the student makes a mistake, they can never get back on track and get any more points. So alternative ways to grade is when he makes a mistake is to reset it to where it was before he made the mistake and tell him to do it again. And typically you will want to not let him get the point for that step, otherwise he may just guess his way to getting it correct. And the third way you can do grading is when they make a mistake, you will actually change the data structure to what it should have been, fix it, and then say, well, you missed that point, you didn't get it right, here's what you should have done, and I'll let you continue from here. To do that, you have to give to the exercise object a fixed state function. And so that has to be able to take whatever the student has and change it to what should have been, which could be complicated. Now sometimes it simply basically boils down to copying the model answer, which is what's being done here. So if you know the model answer is in a particular state, if you copy the user state to that state of the model answer it should be in, then give that back to what the student sees, then you fixed it. And then click handler. This handles what happens when you click on the array. And then setting up some of the callback functions to the buttons, and then setting some variables. And that's the end of our presentation and the end of our series. I hope you found this useful. Thank you for watching.